Hello everyone and welcome to our second practice video about the length of a circular arc. In this video, we're just going to solve some problems. So as I said earlier, we're not going to state whether the statement is true or not. Rather, we're going to solve problems. So without further ado, let's begin. So first problem. What will be the circular arc length intercepted by the central angle when its angle is 300 degrees and the given radius, wait, wrong grammar, forgive me, and the given radius is 5 feet? What will be the arc length intercepted by the central angle when its angle is 300 degrees and the given radius is 5 feet? So this one is easy. All you need to do is just substitute the given, wait, let me just fix my handwriting. Once again, all you need to do is just substitute the given in this formula. S is equal to R times theta. All right? Your R is the radius and theta is the angle. But I told you before in our previous discussion about this one, before anything else, you must remember that the angle should be in radians. However, our angle is in degrees. Therefore, we must convert this angle into radians. So we have 300 degrees, right? So we must convert it into radians. Recall that if you're going to convert a degree into radian, you will multiply it by pi all over 180 degrees radians. Therefore, this shall be multiplied by pi all over 180 degrees radians. All right? 300 degrees and 180 degrees are both divisible by 60 degrees. So 300 degrees divided by 60 degrees, I think this is 5 because 5 times 60, 5 times 60. Yeah. So 5 times 60 is 300. Now, 180 degrees divided by 60 degrees, this is 3. So this is already in simplified expression. We can now find our final answer. So 5 times pi all over 3 radians, we will have 5 pi all over 3 radians. So that's good that we already convert the given angle into radians. Now we shall substitute the angle in radians and the given radius in this formula. So our radius is 5 feet and our angle is 5 pi all over 3 radians. So our final answer would be 25 pi all over 3 radians. Oh, no, not radians. It's feet. Forgive me. It's feet. All right, there we go. But we need to find the approximate answer for this one because pi is an irrational number. And in reality, we cannot exactly find the exact measurement of this one, especially that we have an irrational number because pi consists of uh, more than millions of decimal values. So that would be very hard for us. So we must approximate this one at least in 2 decimal places. So with that in mind, our final answer would be 26.18 feet. 26.18 feet. So we're done. All right. This is our answer. All right. 26.18. That is the arc length. So next, if the given arc length and radius are 2 pi inches and 10 inches respectively, then what will be the central angle? Again, if the given arc length and radius are 2 pi inches and 10 inches respectively, then what will be the central angle? So here, we have a given of the arc length, which is 21 pi radians. No, inches. Oh my God, why do I keep saying radians? And we have a radius of 10 inches. Now we're asked of the central angle. So basically, this one is missing. So what should we do? So this one, you can just use this formula. If we have an arc length and a radius, use this formula. Okay? Because here, this formula is used to find an angle in radians. All right? But let's just say you're in doubt. Like, for example, you do not know this one, or maybe you've completely forgotten about it. Well, it's easy. All you need to do, right? You have this one. Just, algebraically transform this equation into finding this theta. Because if you recall in my previous discussion, I told you a step-by-step procedure about how to transform an equation, or in other words, derive an equation into something else. Like for example, like this case, you were looking for theta, right? Because you'll be looking for the central angle. So all you need to do is make theta alone. So by how? So in this case, we will divide both sides by r. So we will have s all over r is equal to theta. And that's it. Theta is alone here, so we can now use this formula. Now what we can do is we can now substitute. So you have s, which is 21 pi inches all over the radius of 10 inches. So if you're going to get the answer here, you will have 21 pi radians, all right? Not inches, radians. Because here, the inches here are cancelled because there's a unit of inch on the top and on below. So they can be cancelled, all right? And since we have no units, but the number here is an angle, we must represent it with radians. So therefore, we must put it with radian as a representation that this number is not ordinary, or how to say this, or just a constant term, but rather it is an angle. All right? Or we can convert this one into degrees, since the question here, it doesn't actually give a specific type of angle, because there are two types of angles, right? We measure angles in degrees or or in radians, right? So we can simply convert this one into degrees. All right. So we have 21 pi radians. Okay. Recall that if you're going to convert a given radian into degree, all you need to do is just multiply it with pi all over. No, 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 wait. That sounds wrong. It's actually the opposite. It's 180 degrees all over pi radians. All right? Multiply the given degree with this one. So here we will have 21 pi radians times 180 degrees all over pi radians. All right? So we can cancel the pi's. So that will be just 1. And we can cancel the radians. So as a result, we will have 2 pi times 1 times 180 degrees all over 1. So multiplying them together, you will have 2.1 times 180, 378 degrees. 378 degrees. So these are your answers. All right? We have two answers simply because we do not know exactly what type of unit of angle is required. So whether if it's in radians or in degrees. So either way, in case we find the angle both in radians and in degrees. So we have these two answers. All right. So let's now proceed. Find the arc length of a circle when the angle is negative 13 pi radians and a radius of 1.2 kilometers. This one is actually the easiest because here we have an angle that is in radians, so we do not need to convert it into radians since it is already in radians. So all we need to do is just substitute it here. So radius is 1.2 kilometers and a theta of negative 13 pi radians. So what would be our answer here? So 1.2 times negative 13 pi radians, you will have 78. Wait, this is supposed to be negative. Wait. Hold on. So this is, negative 78 pi all over 5 radians. Radians. Kilometers. Damn it, why do I keep saying radians? Okay, kilometers. Okay. If this is your answer, this is wrong. Right? This is totally wrong. Can you guess why? If you're talking about the formula, then you would be wrong as well because the way how we use the formula is completely correct, but the answer is not correct. Why though? Is it because it's not approximated? Well, the thing is, we can approximate it if you want to, all right, but the answer is still wrong if you're going to approximate the answer. So I'll tell you why. What are we looking for again? We're looking for the arc length, meaning the length of the arc. So to put it simply, no, let me give you some example before I will summarize it and to conclude. Imagine this is a square and you want to know the size of the square, right? Suppose you want to find a rectangular shape and you want to find the size of the dimensions of this rectangle. So what do you expect if you're going to find the size of these two shapes? If you're going to find the size of these two shapes, you would basically think that the range should be from 0 up to infinity. It could be 12 inches or 3 centimeters. It could be 4 centimeters, so on and so forth. Or it could be 100 centimeters, or it could be 100 kilometers. All right. So what's my point? My point is that there is no such thing as negative measurement. There's no such thing as negative measurement if you're looking for the length. So here you're looking for the arc length. There is no such thing as negative 78 pi all over 5 kilometers. No. All right. It's like, for example, you are looking for the circumference of this circle. Okay. And let's just say you have a radius of 4. Then the circumference of this circle is basically negative 8 pi. Is this possible in reality? No. Why? When you're talking about circumference, you're basically talking about the sum of all arcs or sides of the circle, right? So we're talking about adding all the measurements of the sides or the arcs of a circle. So there's no such thing as negative measurement because it is considered invalid. Just like a ruler, right? In a ruler, there's like 0 up to 30 centimeters, I do believe, right? If it's just small, I think it only reaches 10 or 15 centimeters, you know? But the thing here is that it's not in negative sign, all right? So, in other words, it should not be in negative, rather it should be in positive. So 78 pi all over 5 kilometers. Not negative because it is considered invalid. I already told you a lot of times. All right. It's like, oh, I want to measure the height of the building. Of course, you wouldn't expect it to be negative, right? Of course, there are some cases where negative is allowed, such as displacement, because displacement is a vector quantity, so it has magnitude and direction. So if it's negative, then it implies that it is in a downward motion. All right, that would be a different topic already if that's the case. Or let's take a look some scalar quantities such as temperature, like negative 10 degrees Celsius. That means it's actually getting colder, or negative 32 degrees Celsius. You get me? But this one we're looking for the length. Okay, not temperature, not any type of vector quantity. No, we're looking for the length. So in other words, make it positive. All right. So now we can approximate this answer. What's that again? 78 uh, pi all over 5. That is approximately 49.01 kilometers. 49.01 kilometers. So that is your final answer. Approximately 49.01 kilometers. All right. So that is your answer. Suppose you have an object that consists of a 2 feet rope and a golf ball. The rope is perfectly tied to golf ball. You rotated the golf ball with the use of a rope in 2 rotations. What will be the total distance traveled by a golf ball? Again, suppose you have an object that consists of a 2 feet rope and a golf ball. The rope is perfectly tied to a golf ball. You rotated the golf ball with the use of a rope in 2 rotations. What will be the total distance traveled by a golf ball? Wait, is it perfectly tied? Is it tight? I am not sure if this is the correct. What I'm trying to point out here, by the way, I could be wrong in terms of the way how I explain it or describe it in English. All right, because what I'm trying to point out, this is the rope, and then there's a ball. It's been tied with the rope. It's like that. You get me? So if is it perfectly tied or not? Is it knotted? Perfectly knotted. But I think you get my point. Let's just say we have a rope and it's connected to the golf ball. All right. So, anyways, what will be the total distance traveled? So suppose this is you, all right, and uh, you have an object that consists of this rope and a golf ball. All right. Then you're going to rotate it twice. So 1 and 2. Now, in here, uh, when it rotates, it actually asks you that what will the distance total distance be traveled by a golf ball. So suppose it starts here. So it goes from here, then it goes another rotation. So it's like you're drawing a circle 2 times. It's like that. It's like this. All right. So what will be the total distance? So we have to recall that in one rotation, it is equivalent to 360 degrees. Or in radians, this is 2 pi radians. So if we have 2 rotations, multiply 360 by 2, you will have 720 degrees. Or in radians, multiplied by 2, you will have 4 pi radians. So in other words, your central angle is 4 pi radians because it reached until the second rotation. All right. Now, our radius would be 2 feet. Okay. 2 feet. All right. I'm not sure if it's perfectly tied. Maybe let's just say connected in some way. All right. Just like this one, basically. But I hope you get my point. But if you think the way how I write it or describe it is wrong, please comment down below. Okay, I need some improvement when it comes to describing a certain scenario. All right. So anyways, let's now proceed. So with that, we can now substitute the formula. So the formula, once again, is S is equal to R times theta. So your R here is 2 feet, and your theta is 4 pi radians. So multiply them together, we will have 8 pi feet. All right, but let's get the approximate value for this one. 8 pi feet in two decimal places, this is just 25.13 feet. 25.13 feet. So that is your final answer. All right? And that is all, guys. Oh, wait, no, no, no. Wait. No. There's actually one more problem. Forgive me. All right? This one. Assume you are an assassin on the roof of a particular building. Your mission is to assassinate two targets, one on your east and one on your west. The targets are on the roof of the building where they are placed. Basically, they're in the rooftop, in other words. The height of the building you are now standing on is the same as the height of your targets. The distance between you and your target due east is the same distance between you and your target due west, which is 5 kilometers. You have a sniper with a silencer, so you can take them out quietly. You eliminate the target to the east first, and then the other by rotating your body counterclockwise. What is the entire length of the distance you rotated if you're curious about the length of your rotation from east to west? So let me give you a visual representation. This is where you stayed, basically. This is you. All right, this is you. Okay. Then your target is on west and on east. All right. It states that the targets are on the rooftop of the building, and the height of the building you're standing on is the same height as your targets. All right. Meaning that the building here on the east and the west are just the same. Okay? They are just the same. Okay? So for example, if the building that you are on, let's just say this is 10 feet tall, then the two buildings here, east and west, are also 10 feet tall. All right? Okay? Now next, the distance between you and your target due east is the same distance between you and your target due west, which is 5 kilometers. Basically, the distance, okay, let me just do, the distance between you and from east is just the same from you up to the west. So it says 5 kilometers, right? So therefore, this is also 5 kilometers. Now, you take them out. You first take out the east, then west. You took out the west by rotating your body in what? In counterclockwise until you reach east. So let's just say this is you, this is the target on the east, and this is the target on the west. All right? So you target them. Okay? So he's dead. Now, what you did is that you rotated counterclockwise until you reach west. Then you eliminate the target. All right? So what happens here is that you're actually forming an angle here. It's like from this going here, you know? It's like a semicircle, you can say that. And because of that, we form an angle of 180 degrees. All right? We form an angle of 180 degrees. With that in mind, we can say that the angle here is, or the central angle is is 180 degrees. All right? Because you start on the east, then you rotate, then you go west. All right? Now, the question is that how long is this one? This curve right here. The one that I'm uh, putting with a red color here. This one. How long is this length though? So it's like you're saying the arc length. And since it's like you move a semicircle, so we can say that this arc length is circular. So how can we find the length of the circular arc? Okay. So of course, we're going to use this formula. Okay, r times theta. Your r would be 5 kilometers since this is u and the distance between you and the east is, the east is 5 kilometers and that's also the same distance between you and the target due west. All right, so your radius here is 5 kilometers. But your theta is once again is in 180 degrees. So you must convert this into radians. So by how? Once again, you will multiply it with pi all over 180 degrees radians. So these two are both divisible by 180 degrees, so we can cancel them out. As a result, we have pi radians. So therefore, our theta would be pi radians. So we have 5 pi kilometers exactly. But in approximate, 5 pi, 5 pi, this is approximately 15.71 kilometers. And that is your final answer. And that is all, guys. I hope you have learned something in this practice video. See you soon.